Hi guys, 3.5 on determining the equation of a polynomial is the next lesson. So here's the factored form of a polynomial. P of x has some kind of leading coefficient, a bunch of factors, and from the factors you can see the x-intercepts by changing the sign. So what we can do is we can figure out all sorts of stuff from the equation, or if we have a graph, we can figure out what the equation would have looked like. So here's the information you may be given in a question or a graph in order to write the equation. The roots, aka x-intercepts, which are, as I said, the opposite sign of the factors. The multiplicities of the roots, so whether they're a bouncer on the graph or they cut through the x-intercept, the degree of the equation, and a point on the graph, some random point that goes through this graph, x, y. If you're given some or all of this information, you can sub it into this factored form. Remember, this is called factored form. And you can usually solve, what we're looking for usually is A. That's what we're not given, and we'll solve for that last thing. First example, a polynomial function has zeros at -3 and 4 and passes through the point 1, 15. The multiplicity of -3, 0 is 1, and the multiplicity of 4, 0 is 2. Find P of x. So what we know here is we know the zeros. So we know that when we put these in the polynomial function, we're going to have brackets that have x. But in order to know what the zeros are, what did we do to the number in here to get it? We flipped the sign. So if the 0 is at -3, if the x-intercept is at -3, the bracket had to have said +3. And same thing for 4. If the x-intercept is positive, the factor or the bracket had to say -4. The other thing I can put in right away is I know there's going to be some leading coefficient. I don't know what it is though from what we're given. They also tell me the multiplicity of -3 as your x-intercept. That's what happens when you see a 0 in the ordered pair. You know it's an intercept, is 1. So that means that this bracket here has an exponent of 1. Draw it if you like, but you don't have to. The multiplicity of the x-intercept 4 is 2. Put a 2 as the exponent on x minus 4. Now this is the first step. Here we've got a good jumping off point. We now have to put in the numbers that we know, because right now there's way too much that we don't know in order to solve for A. I'm going to write this in a slightly different way and see if you can figure out what I'm doing. So if you caught that, all I did was I said, well, function notation just is the same as saying y equals, so I replaced p of x with y. The reason why I did that is because this is the last piece of information, the point 115, that we need to incorporate into our equation in order to find a. This is a point. Points always have the x-coordinate first and the y-coordinate second. We have an equation right here with a whole bunch of variables that can become numbers. Our y can become the number 15. Our x's, both of them, can become the number 1. All I've done is rewrite the equation, and instead of writing x's down, I wrote 1's, and instead of writing the y down, I wrote 15. That's all I did. Now this is just a BEDMAS question, a little bit of algebra. So what do we do first in BEDMAS? We do anything in brackets. So 1 plus 3 is 4. 1 minus 4 is -3. I can now continue with BEDMAS and I can apply the exponent, -3 squared. Be very careful. The brackets are essential. If you put in your calculator right now -3 squared without brackets, it'll tell you -9, which is wrong. This is -3 squared, which is repeated multiplication of the number -3. What is -3 times -3? Well, two negatives make a positive. Your calculator without brackets will tell you negative, but the correct squaring of -3 is +9. Common mistake that we see students making there. Now, if you wanted to keep going, the next thing in BEDMAS is to multiply things together. I see some things right here that could multiply together. So we have 4 times 9 being 36. Now, remember, you can write multiplication a lot of different ways in math. We are not used to seeing a times 36. What are we more used to seeing if we want to multiply a and 36 together? 36a. This is my big hint to you. Even though that becomes 36, if it's multiplying, write it in front because we're way less likely to recognize this than we are this. This is what we have basically trained you guys to know, but the a times 36 just looks quite bizarre, to be honest. If you write it the second way, you can now see what kind of algebra we need to get a by itself. We need to divide both sides by 36 so that the 36's cancel and we get a to be a fraction. It's 5 out of 12, but that's totally fine. We're not afraid of fractions. And then we reread the question. The ultimate question asks us to find p of x, actually find the whole polynomial function. So although this is what we needed, we actually have to answer the question now. We have to say p of x equals, and I'll slide back up because it is, oh my, way back up. It is right here. All we have to do is we have to put our value in for a now. So we have to put 5/12, x plus 3, and x minus 4 squared. This is now a polynomial function that you could put into your calculator and you could actually take a look at the x-intercepts, the end behavior, all sorts of stuff. Trying another one. Determine the equations for the following. Roots at 3, 4, -7, and passing through 2, 54. So we can only go with the information we're given. If they just tell us the roots, we're not going to put multiplicities of 2 or 3 or 4 on them. We assume the multiplicity is 1. So we've got some unknown polynomial function that has an unknown leading coefficient, and it has roots at 3, 4, and -7, which means its factors are x minus 3, x minus 4, and x plus 7. Remember that the signs change when the x-intercepts go into the factors. Now this p of x, remember, is a fancy way of writing y. So I'm going to replace it with 54, which is a y value, and 2, which is the corresponding x value. Now, this whole part here, we could put in our calculator, but it's quite simple math if we do it in the right order. So I want us to do the brackets first. So 2 minus 3 is -1, 2 minus 4 is -2, and 2 plus 7 is 9. Now multiply these in your head if you can. What's -1 times -2? +2. +2 times 9, 18. Write the 18 in front of the a so it looks familiar to you, so that it doesn't look like a times 18, which is bizarre. One algebraic step will solve for a. 54 divided by 18 is a nice whole number 3. And then actually answer the question by telling us that p of x is equal to the a value we just found plus all of the factors that we started with. If you're feeling comfortable with this, feel free to pause the video and try the next one, and then we'll come back to the solution right now. Okay, roots at x equals 4, multiplicity of 3. So x minus 4, multiplicity of 3. X equals 1 is an x-intercept, so x minus 1, multiplicity of 2. Unknown leading coefficient a. And we call it p of x for polynomial function, but you could call it f of x, you could call it y, it doesn't matter. I'm passing through the point 0, 32. As soon as I see the 0, I'm hoping that you're thinking, okay, x is 0, that's a y-intercept, but it still doesn't change what you do. You sub in x and y into your equation, and you're really happy that x is 0 because that makes the math quite simple. Here's my 32 for y. Here's my zeros for x. And now I evaluate. 0 minus 4 is negative 4. Cubed is negative 64. 0 minus 1 is negative 1. Squared is positive 1. I really didn't have to write the positive 1 down because multiplying by positive 1 doesn't do anything. So I've got negative 64a equals 32. And if I go ahead and divide, keep your negative, it's important. I'm going to get a equal to negative 1/2. And my polynomial function that I was after the whole time looks like this. One last example that you can pause the video and try yourself. This polynomial function with unknown leading coefficient has x-intercepts at 0. Now, you could write a bracket with x minus 0 in it, but x minus 0 is just x. You can put it in a bracket if you want, but x times a is just ax. And then we've got x plus 4, no multiplicity stated, so we assume it's 1, and x minus 2, multiplicity 2, passing through a y value of 128, an x value of negative 2, and we'll evaluate. We've got a times negative 2. This bracket equals 2. This bracket equals negative 4. Squared is positive 16. And then I'll multiply 16 times 2 times negative 2. And I'm going to get negative 64. I'll write it in front of the a so it looks familiar to me. I'll do algebra, dividing both sides by negative 64. And I'm going to get a to be negative 2. And therefore, the polynomial function that represents this description is negative 2x, x plus 4, x minus 2 squared. You'll notice any function still needs to have x's in it, and it still needs to have a y. You don't leave the negative 2 and the 128 in the equation. Otherwise, it's just a bunch of numbers. In order to graph something, you need x's and y's. So you take those back out, and you basically write the first part with a as the number you found. So this section has a worksheet listed on the website with an answer key that you can work through. Email me if you have any questions.